stand in front of a mirror in our house, we see a clear image of ourselves. To understand how an image is formed in a mirror, let us first consider an image formed by a point source. Light rays coming from a point source travel in all directions. Several of these rays fall on the mirror, get reflected, and reach our eyes. Due to reflection, they appear to be coming from a point behind the mirror. That point is the image of the point source. Let us consider a point source O placed in front of the plane mirror M1, M2. Let rays OR1 and OR2 incident on mirror M1, M2. According to the laws of reflection, the incident rays get reflected along paths R1, S1 and R2, S2 respectively. When these reflected rays are extended behind the mirror, they meet at O1. The person looking into the mirror from position E sees that the reflected rays appear to be coming from O1. Other rays starting from O also get reflected and appear to be coming from O1. This point O1 is the image of point O. It should be noted that the reflected rays do not actually meet. Hence, such an image is called a virtual image. The perpendicular distance of the image from the mirror is equal to the perpendicular distance of the source from the mirror. Let us now understand the formation of image of an extended source in a plane mirror. If we use an extended source instead of a point source, an image is formed of every point of the source, thereby forming an extended image of the whole source. Let us consider an extended source PQ kept in front of the mirror M1, M2. The images of P and Q are formed at P1 and Q1 respectively. Similarly, images of all points between P and Q are formed between P1 and Q1, resulting in the image P1, Q1 of the entire extended source. Observing this setup, can you tell the size of the source and that of the image? Yes, the image formed by a plane mirror is of the same size of the source. Let us now do an interesting exercise. Write all the letters of the English alphabet on a cardboard. Now hold the cardboard in front of a mirror. We see laterally inverted letters in the mirror. Do you know why does it happen? The image formed by a plane mirror is virtual, upright, and of the same size as that of the object. The image of every point on the letter is formed behind the mirror at the same distance from the mirror as the point itself. This is called lateral inversion. Out of all these letters, A, H, I, M, O, T, U, V, W, X, and Y are the letters of the English alphabet that form images that look the same as the original letters. Isn't it interesting? Come, let us now quickly note down the characteristics of the images obtained in a plane mirror. When a person stands in front of a plane mirror, the characteristics of the image obtained in a plane mirror are: the image is erect. The size of the image is equal to that of the person. The image is as far behind the mirror as the person is in front of it. The image is laterally inverted with respect to the person. The image is virtual. Now it's time to perform an activity. Take a drawing paper. Now using the ruler, draw a line, say OA, on the paper. Using a protractor, draw lines OB, OC and OD, making an angle of 30 degree, 60 degree and 90 degree with the line OA respectively. Now take two mirrors. Place them along OA and OD such that they are perpendicular to each other. Place a lighted candle between the two mirrors. We can see that the images are formed in both the mirrors. How many images do we see? We see 3 images of the candle. Let us note down our observation in a table. Now let us change the angle between the mirrors. Shift the mirror placed on line OD to OC such that the angle between the mirrors is 60 degree. This time, how many images are seen? We see 5 images of candle. Next, shift the mirror placed on OC to OB such that the angle between two mirrors is 30 degree. This time we see 11 images of the candle. In the same way, if we keep two mirrors at an angle of 45 degree, then we get 7 images. And if we keep two mirrors at an angle of 120 degree, then we get 2 images of the candle. If we study the observations, we come to know that there is a relationship between measure of the angle and number of images. It is given by the formula n is equal to 360 degree upon a minus 1, where n is equal to number of images and a is equal to angle between the mirrors. Let us now check if the number of images obtained for different values of angle is consistent with this formula or not. If the angle between the mirrors is 90 degree, then the number of images formed will be 360 degree upon 90 degree minus 1, which is equal to 4 minus 1, which equals to 3. Thus, 3 images are formed when two mirrors are placed at an angle of 90 degree to each other. The number of images observed during an activity and the number of images obtained using the formula is equal. If the angle between the mirrors is 60 degree, then the number of images formed will be 360 degree upon 60 degree minus 1, which is equal to 6 minus 1, and that equals to 5. Thus, 5 images are formed when two mirrors are placed at an angle of 60 degree to each other. The number of images observed during an activity and the number of images obtained using the formula is equal. If the angle between the mirrors is 30 degree, then the number of images formed will be 360 degree upon 30 degree minus 1, which is equal to 12 minus 1, which equals to 11. Thus, 11 images are formed when two mirrors are placed at an angle of 30 degree to each other. The number of images observed during an activity and the number of images obtained using the formula is equal. In the same way, we can verify the number of images obtained when the angle between the two mirrors is 45 degree and 120 degree. Now, can you tell the number of images that will be obtained if an object is kept in between two mirrors that are parallel to each other? Yes, you are right. If the object is kept in between two mirrors that are kept parallel to each other, the number of images formed will be infinite. Let us now prove that in order to see the full image of a person standing in front of a plane mirror, the minimum height of the mirror must be half the height of the person. This can be proved with the help of a schematic diagram. Here, HF represents the person standing in front of a plane mirror PQ in such a way that PQ is parallel to HF. The mirror PQ is at a height of NQ from the ground and is perpendicular to it. H1, F1 represents the image of a person standing in front of the mirror. Points H, E and F correspond to the top of the head, eyes and the feet of the person respectively. Point R is the midpoint of HE and point S is the midpoint of EF. Incident ray HP gets reflected as PE. Similarly, incident ray FQ gets reflected as QE. PQ is the minimum height of the mirror in order to obtain the full image of the person. For this, RP and QS must be perpendicular to the mirror. Thus, minimum height of the mirror PQ is equal to RS, which is equal to RE plus ES. But RE is equal to HE upon 2 and ES is equal to EF upon 2. Substituting these values in the above equation, we get PQ is equal to HF upon 2, which is nothing but half the height of the person. This shows that in order to see the full image of a person standing in front of a mirror, the minimum height of the mirror must be half the height of the person. Come, let us now proceed to study about spherical mirrors. Plane mirror. Plane mirrors are used in various activities in our daily life. A mirror is made by coating the back surface of a flat and smooth glass piece with a thin reflecting film of aluminium or silver. To protect this reflecting film and to make that side opaque, another coat of a substance like lead oxide is given over it.